Good day, everyone. Maybe good night for some of you. Welcome to our webinar series on resilience engineering. My name is Tarcisio, and I will be the chair today. This webinar has been co-organized by several people from three organizations, namely the Resilience Engineering Technical Committee of the International Ergonomics Association, the Resilient Healthcare Society, and the Resilience Engineering Association. This webinar is part of ongoing efforts to join forces across these organizations to support theoretical and practical advances in resilience engineering. And this also follows the last year's joint symposium of both resilience engineering associations that happened in Brazil last October. Several of the organizers are here in the audience. Special thanks to Antonio, Inger, Anthony Smoker, Ricardo, who is our technical committee chair. Thank you all, and thanks to the IEA staff for their technical assistance. I think Rose from IEA is here with us. Well, our guest today is Professor Mike Rayo from the Ohio State University in the United States. Dr. Rayo is an associate professor in the Department of Integrated Systems Engineering, where he also serves as core faculty at the Translational Data Analytics Institute and directs both the Cognitive Systems Engineering Laboratory and the Co-Engage Laboratory. Mike's research focuses on enabling adaptive joint human-machine performance across a range of settings, from small teams to large organizations, while promoting proactive safety practices that engage all organizational members in maintaining safe and efficient operations. Mike's research also advances the concept of societal scale resilience by reimagining community collaborations as inclusive and balanced forms of teamwork. And today, Mike's lecture will address the connections between artificial intelligence and resilience engineering, which is indeed a hot topic, as you know, like everything that involves AI these days. Mike's presentation is expected to take approximately 40 minutes, and it will be followed by approximately 15 minutes of questions and answers. You are encouraged to use the chat to post your questions and any other comments that you think are relevant. And yes, I think that's all from me. Mike, thanks again for being here with us. We are looking forward very much to your presentation. The floor is yours.
Excellent. Thank you so much, Tarcisio. And thank you to IEA, REA, Human Factors Ergonomics Society, Technical Group for Cognitive Engineering and Decision Making for your help. And last but not least, the Resilient Healthcare Society. Very excited to speak to all of you together. So however you got here, welcome. Good morning, good afternoon, good evening, good middle of the night if we have folks from there. And actually, what I'd like to start, Tarcisio did a great job talking about all my different hats. I do have a new one, and that's on here as I'm also a distinguished faculty fellow for Joint Human AI Systems, which is an extension of my work with the Translational Data Analytics Institute. Now, I would like this to be as interactive as possible, and I'd like to start. If you could all hit the chat and just tell me where you're coming from, and I'll just keep looking kind of at the chat as I'm going through the first couple slides. I would love to know, just where do you come from? Where are you listening from? I'm always very excited to hear where folks are coming from. So our first two on the board from Canada, nice work on there. I'm seeing some Columbus. Oh, that's coming way too fast, but I'm seeing a good mix of, this is lovely. Well, I'll keep going back through that. So what I want to do today is I have two objectives. And the first thing I want to set or reset expectations about AI-infused technologies in, oh, by the way, I am going to lean heavily because this is my first talk in front of the Resilient Healthcare Society. I'm going to put all of this in a healthcare setting, but I want you all to take your mental highlighters out, and every time I say clinical, you can translate that to safety critical. Anytime I say clinician, you can transform that into operator. This talk is about all safety critical industries, but I'm going to put it in a healthcare setting. So I hope that's not off-putting to anyone else. Um, that's not in healthcare. So again, first we're going to reset expectations about AI-infused technologies in safety critical settings. And then I want you to be able to identify AI-infused technologies that contain risks to the joint human AI system. And I'm still seeing, I got some folks from Rome. I got some folks from, most folks from Japan. Thank you for coming in so late in the evening for you. Excellent. I'm super excited to talk to y'all about this. I do have one other thing that we're going to do here. Oh, first, my acknowledgments. This was made possible by a number of different parties, um, but all of these opinions are mine. All right, here's the next thing. I want you to feel, I want to know how everybody, where everybody's coming to. Maybe you've seen one of my talks before. Maybe you've seen something about joint systems. Maybe you understand that terminology. Maybe you think that's the way of the future. Maybe you don't. What I want you to do is if you can find your voting buttons, those are sitting in the place. Oh, just something bad happened. Hold on. That's not what I want. There we go. Um, your voting buttons are. I've lost my voting buttons. I guess I'm not allowed to do that while I'm speaking. Well, if you know where your voting buttons are, it should be some kind of react button in your menu. Um, I want you to raise your hands digitally. You can do the hand raise. You know, if when you think about when you hear joint human AI systems, you say, "Oh, what does joint human AI systems even mean?" So those of you, and you can answer multiple of these if you want to. And I'm going to try to figure out how to see who's voting on what, or if we even know how to vote. So I see one, two hand, a couple people. So vote, you found your hand raising buttons. That's great. So a couple people. So I'll make sure to go through that about what joint is. Okay, now you can lower your hands. Second, I know what joint is, and I'm not convinced yet that joint human AI systems are important. Can't AI just do it all? So if you're in that camp, please raise your hand. It's nice to see your hand raised, Peter. All right, you can lower your hands. Next group. I'm convinced that joint human AI is important. Joint human AI systems is important. And give me more ammunition or findings. Like, let's talk about the findings so that I can convince other folks that it's important as well. You could raise your hand for that. Looks like we're settling in there. Okay, that looks like that's a big winner. I'm gonna definitely talk about that. And then the last one, I'm also convinced. This is still like I'm convinced. But instead of findings, not instead, but this one is about give me more information. Help me design better joint human AI systems. Give me not just findings ammunition, but actually give me some of the tools I can use to design those myself. And again, raise your hand for that. Oh, that seems to be the big winner. Although I'm going to cover all four of those. The secret here is I have way too much that I could talk about. I needed that help, so thank you so much to help me understand what I really should be talking about more and what I should be talking about less. All right, y'all can you can lower your hands. Thank you so much for that. So you've interacted twice already, and that that I'm really excited about that. All right, so let's keep going. So in this age of AI, on this day in April of 2026, I see the big loud voices are the AI hype peddlers. that these are superhuman, these are almost deities. They can do anything, they can do everything. They even though they are from us, they are superior to us. We just have to kind of get out of the way and let them cook. And then there are the AI doomers. The AI is going to lead to, so you have Agent Smith on the left from the Matrix, you have Terminator from the Terminator on the right, that this thing, this is Skynet, this is going to result in apocalypse. And both of those voices are very, very loud. And by the way, I created both of these images using the latest version of ChatGPT this morning, and I'll show you why in just a second. I wasn't just wasting water and natural resources to do it, but these are the big loud voices. Now, there are there for as I said, I'm running a program called the Joint Human AI Systems in an agentic world theme at Ohio State. Shameless plug. We're always looking for folks to talk to. If you want to learn more about us, you can hit this QR code. And we've been able to connect with a number of people, a large number of people in practice, in academia, who are very well steeped in this. And with those folks, you don't get a lot of the doomers, you don't get a lot of the hype peddlers. And again, this is from industry, from these folks that are actually building these machines, as well as academics who are studying them and building them themselves, and everybody in between. You don't get those kinds of things, but what you do get is kind of an AI how it started, and then AI how's it going, how it's going. So AI how it started. Oh, but this helps me. It helps me do this thing. It helps me write better, not better code. We'll get that in a second. It helps me write more code. It helps me write it faster. It helps me get my papers out. It helps me do it faster. But it helps me. Why? And I have been picking on AI a lot. So that's why, Rayo, why are you picking on AI so much? That's how it starts. That's how it started. But very recently, and these stories came out 2 days ago. And this an AI agent just destroyed all of our production data. This just happened to a small didn't hear, but it basically, like, a really short version. The LLM that made those pictures um, violated its own guardrails and then couldn't show me the picture at first. I switched it, so I took off the mention of the Justice League. Then it could show me. Then I was like, well, let's get cheeky and let's actually say, can I rip off somebody's copyright and have it go through? And I got it to do it just about right away. So that's the short version. I can go back and maybe we can fix this in post to get back to the longer version. But I have so many other things to talk to you about. I'm going to keep going. So I also want to talk to you really quickly about, and we're going to touch on this, is again, we're trying to anticipate. We have these methods to anticipate what's going to go on. What is a high functioning AI and joint human AI system, and what may be a vulnerable or brittle system. And we're going to look at anecdotal. And I'm going to show you a couple anecdotal pieces. What happened once. In fact, the vibe coding and the Pocket OS issue were anecdotal, happened once. We're going to talk about evidential. This is patterns of what happened. In healthcare, the randomized control trial is the pinnacle of that. And then mechanistic, and this is where we get more into kind of engineering epistemologies or traditions, and this explanation of why. We're going to talk about that as well. So the way I like to start my talks, and I'll do it really quickly here, is, would you bet your life on it? Would you bet your life on this AI technology? Would you bet your life on this new thing? And I don't think I need to belabor that with this crowd because we all, I'm assuming we all work in these safety critical industries. And so we know what the stakes are. And honestly, once you get past this, would you bet your life on it, even though it gets people to think in a certain way, it's actually not very productive. So what I want to do is expand that and extend that. And I want us to think about what this envisioned. Now, this is HMT, human machine teaming. Sorry, that you can, again, substitute joint human AI system. We have this envisioned idea that, okay, the machine is highly competent in some areas. That's over on the left. The human is highly competent in others. That's on the right. And then, when we put them together, voila, the HMT, the human machine team, that joint human AI system, it's better than either alone. Like, that's what happens. That's just going to happen out of the box because that's just what's going to happen. But what we actually find, is it most of the time? Is it some of the time? It's a non-trivial amount of the time. is that it actually is worse than the machine only, and these are some of the studies that show that, worse than the human only. So it actually shows uh, worse performance, degraded performance relative to that because, and we're positing that that's because that jointness isn't well designed for. So you can't just get it um, for free. You can't just get it without trying. And so what we want to start thinking about is if we design for solo AI performance, that failure will be brittle. If we design for joint human AI activity, that failure will be graceful. And actually, if we design well enough for jointness, we won't get failure at all. We'll gracefully extend. So let's talk about what that again for those folks that are like, what is that jointness thing? What we're talking about here, and I'm going to actually talk about it in terms of architecture. A joint activity is a set of two or more agents working together to perform activity. Now, we are focusing specifically on the word activity that's drawn from the French translation, which is the actual work that is being done. The work is done. And these should be, for some of you, these should be, oh, yep, I get it. Work is done. I know what we're talking about. Not the formalized, often distorted view from afar. That work is imagined. So we're thinking about work that is done. And an architecture is the conceptual structure and logical organization of, in this case, a system. So you put those things together, and it's this joint activity architecture is a set of possible ways to organize how multiple parties can and do work together to jointly perform an activity. And what we see is that there are intended joint activity architectures. This is what the designer thought was going to happen. And then there are emergent architectures. This is what actually happens. So there's actually an architecture as done, an architecture as imagined. And as we know, there's architecture that's prescribed and all kinds of other things as well. So, so we want to think about how do we design for a way of people and technology working together in a way that actually sustains through implementation. And why do we care about jointness in the first place? Hopefully, every single one of these slides will help confirm this, but I want to, rest on some bedrock here. I want to rest on the theory of graceful extensibility. For those of you who've read it, it talks about a whole lot of things at length. What I want to focus on are these 5 proto-theorems. One, every unit, a unit could be a person, a unit could be a group of people, a unit could be people and technology together, a unit could be an entire organization. All units risk saturation and require the ability to extend. No unit can manage that risk by itself. It has to coordinate with others. Neighboring units can affect the ability of that unit, and a unit can affect its neighbors. All adaptive units are local and constrained, not only in what they can do, but what their perspective is. There's no omniscient location, and all perspectives are limited. Again, this all says to us we need to work in this together. That means AI and people need to work together. Okay, so let's talk about these anticipation techniques. We're going to start with the $1 method. This is how we should all get started. How do we anticipate how this AI system is going to work? And I start with 6 questions. And these 6 questions get us to a kind of rough answer about, is this solution, are these people I'm talking to, are they serious about joint activity? And here they are. By the way, these questions tend to make people upset when I ask them, but they're really important to get at what's really going on and how is this technology going to work? So one, how does the technology know it's wrong? Second question, how well does it know it's wrong? Third question, how does the technology communicate when it's wrong? Fourth question, how well does it communicate when it's wrong? And the fifth and the sixth one really are doozies. This is what gets people's head hurting, but we're going to show you some of the ways that you can do this. How does the technology provide cues that it's wrong, even when it doesn't know that it's wrong? And then how well does it do that? So every one of those questions on the left, those are design strategies. We can ask, what did you intend? Again, what are your intended design, your intended solutions? What are your intended architectures? And then we're to actually observe and evaluate on the right. How well is it doing it? How well is it performing the way you thought it should? And you'll notice I don't have any questions on here about like how usable is it? Those are really important questions to answer. These are in addition to that. So really quickly, what could that look like if I'm using, again, I'm going to use a healthcare example. I have, say I have this patient. I've got some technology that's helping me monitor the patient, and I'm a clinician trying to work with all this kind of stuff. And again, this envision process is I I have perfect AI tool execution. I've got high quality data. I have perfect algorithms. Um, I have it gives me high quality insight. I get, better, cheaper, faster, all the good things. I get better diagnoses and plans in less time. That's the envision process. And oh, by the way, we all know that they're not perfect, but we just assume that any of those imperfections are negligible. Now, for those of you who've worked with some of these systems and some of these environments, what we know is that it's going to be imperfect tool execution to get that data. We're going to have some, which means we're going to have spotty or incomplete data. We're going to have imperfect algorithms. And then this is the crazy part, and this slide was actually written a number of years ago before the heyday of LLMs. LLMs have turbocharged this problem. We have confident, very confident, but sometimes, oh, sorry, LLM, large language model, um, sometimes incorrect insights. And what this means for the clinician is it's good when, and that's operator, it's good when things are normal and brittle when anomalous. We have potentials for both misses of important things and overreactions. And so what we need is to be able to, what we call, machine fitness assessment. We need to be able to assess how the machine is doing. And what that means is, things on the left side, does this result seem right? Should I check it again? Should I believe this? On the right-hand side, can do I have everything I need to be able to do that devil's advocate checking as well? Not just, checking the components, but like the output itself. Should I be digging in further? Should I believe this? And does it give me the right kinds of data, the right kinds of signals so that I know when it's time? Oh, by the way, those are both machine fitness assessments. Is the data going into the tool? Is it okay? Is the stuff that's coming out of the tool, is it okay? And that's all going to give me signals about whether I need to go reach out directly to the world, in this case, the patient. And this is non-trivial because these clinicians are doing a lot of different things, and the hype and the hope is that these things are going to reduce the work, that burden of work on the clinician. So we can't reach out directly to the patient every time. That misses the point. So when are those times where they need to reach out directly? Here at Ohio State, we have actually developed new tools that go all the way from the very beginning, including those $1 tools, from envisioning and seeing futures all the way through to post implementation. I'm going to hit on each of them very briefly. Happy to send more information, especially now that I lost about 5 minutes. Um, but we have these joint activity design heuristics. We have joint activity design patterns. We have a joint activity testing methodology, which is empirical testing, kind of like usability testing, in that you have people actually working with technologies, not like usability testing, because we're actually looking at performance of these activities with the technology. And then proactive monitoring post-implementation. All right, so I showed you the $1 method. Let's get to the $10 method. And this is going to help me answer what kind of joint activity problems do solutions like this face, or would a solution like this face? And this is the heuristic evaluation. So we've developed a set of 14 heuristics. They very explicitly, intentionally focus on the different macrocognitive functions that AI tends to be assisting people with. Event detection is one of them. What's going on out in the world? Sense making is one of them. How do I interpret what I see coming out of the world? And then, sorry, let's go down to the bottom. Human machine coordination. How are the people and machines working together? But then also, we have, these other really important things for coordination, being able to leverage and harness human adaptability, as well as joint perspective shifting. Lots more there. You can go check out the Jelian article on that. Happy to send you there if you want more on that. We're also in addition to the heuristic evaluations, we are developing a set of design patterns and testing them to see, how can we do a little bit better? How can we do a lot better as we think about machine fitness assessment? One of the big things, one of the biggest issues we're trying to face is what's called the framing effect. And the framing effect is basically when a machine or any other agent gives you an answer, or gives you input before you've gone through your sense making process, your sense making process is incontrovertibly changed. We can go into more of the details on that, and I think we have some experts on that on the line as well. AI-based technologies are very prone to this framing and to this priming that is difficult for people to recover from, especially when machines are wrong. So we've a number of these design patterns trying to fix or trying to mitigate this problem. One is to situate like the big red bar, that's my AI output, situate that with a high density data display so I can see the underlying data in the world, which is also the underlying data that moved and worked into the AI tool. That's actually shown really great promise in general being able to recover from false alarms and poor performing AI. We also have been thinking about what if we provide more vague inferences? So if we're not as prescriptive with what the AI thinks is going on in the world, but just is a little bit more abstract or vague, can that break some of the effect? So a little bit more exploration is necessary. Actually, we're seeing really good findings with that as well, where the ultimate frame that the human uses to see that situation is delayed, which is exactly opposite of what we would expect when an AI by itself is giving an inference. We would expect that framing would happen early with the person, the operator. When coupled with this high density data display and the more vague inference, we're actually seeing increased exploration before the selection or adoption of a mental frame from the person. And then the third one is providing indirect inferences. So if we think it's really important for the person to come up with a concept of concern for a patient, if we give an AI that also gives them concern, then that will, that exacerbates that framing effect. If instead of concern we give them urgency, which is actually very similar, some of that effect is attenuated, and we're seeing really interesting results with that as well. So we're trying to break, to kind of crack into this in a bunch of different ways. And what we see is nurse correctness is better with all of these different techniques. So I'm going to keep moving. Um, we see, old AI issues moving to new AI issues. This is the other side. We used to call these anti-patterns, but they're not. They're just more patterns. We have this idea that the clumsiness of old AIs has been replaced by the sloppiness of new AI. That means that the error isn't just in difficult situations. It can happen pretty much any time. We went from interrogable AI in the past to inscrutable or black box. We're left to guess at the process that led to the result. We went from a more literal minded, because it had a structure underneath it, AI, to a generative where yes, there is a structure, and that structure is unknown to anyone. So we have no quality guarantees, and I can't stress that enough. There are no quality guarantees with a fully inductive AI tool. It went from incoherent when it was wrong in the past to now quite plausible. It's increasingly believable even when it's incorrect. With respect to joint activity, we had, things that, very limited joint activity to still just as limited joint activity, but now illusory. It talks to me. It evokes emotions in me. It has all these things. It must be human. We must be engaged in this joint activity, but we aren't in any way that looks like joint activity with people, or a lot of those are still attenuated. And we have hidden global dependencies. Those pictures that I generated while I was sitting here in Columbus had affected by events around the world, or in some cases beyond the satellites that are zooming around our planet. So any of those things could affect the thing I'm getting, my ability, my ability to even get an internet connection that went awry 5 minutes into a presentation. All of those are from global dependencies. All of these make joint activity with LMs more difficult. So the detecting, the sense making, the coordination, all of the other cognitive functions that we need to engage in for joint activity, all of those are more difficult with the LLMs that are coming out right now. So what does that actually, what happens with area? What are we seeing? So this is anecdotal, but this is what we're seeing. A study finds, this is about a year old now, that AI tools made open source developers 19% slower. The funniest part is they thought they were 19 to 20% faster, but they were actually slower. There are some methodological issues with this study, but it points to that there's no panacea here. We also, another study, this one's coming, I think this one out of MIT, and we found, that your brain patterns when using these AI tools, they change. The The trend that we see is that less critical thinking were used from these participants as they used it longer. This was a 4-month study, and more copying pasting, less tailoring and contribution from the person, which means less involvement in joy activity is happening with these tools. So I got you the $1 method. I got you the $10 method. Let's get to the $100 method. And this is empirical testing. So what JA problems am I likely facing? And so we actually built a new method called joint activity testing. We saw some gaps with traditional methods. One, it was very difficult with those methods to extract the value of the joint activity itself. It was very difficult to extrapolate out of the testing set we use. We know that every testing set is going to be limited. We can only do so much testing. Couldn't interpolate between the cases. Again, difficult. Um, Most of that testing made assumptions about case difficulty. We said, oh, this is a hard case and this is an easy case. And what we found is that when we actually put it to the test, some of the cases that we thought were hard turned out to be easy. Some that we thought were going to be easy turned out to be hard. And it was with all of those things, it was actually very difficult to transition the evaluation results to real-time operations. We were constantly being surprised. So what we did is we set up a test that allows us to set up our analysis like this. We plot performance versus challenge. We had a number of performance measures, a number of challenge measures. It doesn't have to be one. And we could actually graph the relationship between performance and challenge for all of those different combinations. Now that means that we would actually set up a wide range of challenge, but this is actually from real data that was really used in the AI to train the AI. So you'll notice that these aren't, nicely, evenly distributed, gradations of challenge. This is actual cases in the real world, and this is how they came to us, that we could then put into our test. We actually ran participants. This is their performance level. We had more than 5 participants, but we're for this one we're just show 5, and this is actually how they performed on all those different cases at all those different levels of challenge. We then run. You can see the kind of the connect the dots method of the central tendencies at each case, and then we can actually model that with a number of different regression curves. And so then we can actually see, how did condition A combine or compare to condition B. You can see in this case, the orange line started out great, but once the challenge got a little bit more difficult, actually had what we would consider more brittle performance, not resilient, not extensible performance. And so, and we've actually seen this with decision makers and sponsors. And when we showed them this, they're like, "Yeah, we just thought we were on the left side. We didn't understand the stuff on the right side. That's unacceptable performance. So we have to keep going on our design." And then I guess this is like the $110 because we can actually use a version of joint activity testing to go post implementation as well, instrumenting how people are using technologies, utilizing operational metrics, and being able to show this unobtrusively, without a considerable amount of research use, because this is actually out in production to see how is it doing? Is performance drifting? Is AI performance drifting? Is joint activity performance drifting? Is the world changing? And we can see how that performance could be affected by different challenges and how a single challenge measure could affect multiple measures of performance. So this grid is like our control room for or our control bay for seeing how joint human AI system performance is doing after deployment. So how does this help? How are we using this? The first thing that we used the heuristics on was to get through the misleading label of alarm fatigue. Since then, we're also thinking about how do we see through the overwhelming hype. This is the first example where we needed to design auditory alarms for our nursing for our nurses, our bedside nurses across the hospital, and we need to first understand, were there any problems with the current alarms? Because the easiest thing to do is say, well, they have alarms here. We're changing the underlying technology. We don't want to change the alarms. Maybe there are too many alarms, so we'll reduce the number of alarms. And what I knew from the literature, actually from a lot of the literature that we used to build later used to build the heuristics, was a lot of these alarms weren't identifiable, even to folks that have been hearing them for years or even decades. So that's the first thing we tested was one, I'm going to go right to left here. I'm not sure exactly why. There were a number of, with the baseline, the cardiac crisis, which is arguably the most important alarm, baseline identification was like under 57%, under 50%, 57% of the time where nurses heard this in our experiment, did they identify cardiac crisis correctly? And you can see very similar, cardiac other, which is just a lower urgency alarm, 42%. Some of them did better, but not great performance. And we said, well, we should try to do better than that. So we actually designed a new set of auditory alarms. We also found that urgency that's conveyed by those alarms got kind of bunched up. So the really high urgency alarms did pretty well. This is the stuff on the left, but there's this kind of bunching in the middle, which means the nurses weren't decoding the urgency of the patient situation. And when we changed the auditory alarms, we got a much bigger delta between high and medium urgency alarms and medium and low urgency alarms. So a fundamentally different problem than we thought we had. We've also more recently used these methods. This is starting with the heuristics and continuing through joint activity testing. And this study was published in Nature Digital Medicine. We set up 4 different situations with an AI algorithm assisting, and we started with just a high density data display. This is the representational aid. We used a black box algorithm where we could just see the big red bar that was telling us what the AI outputs were going to be. We did what's called a salience algorithm. It's the same algorithm, but actually displaying some of the underlying rationale, what it was concerned about, and then an observable algorithm where I could see the recommendation and annotations visually. And um, and what we wanted to start to understand was what was the relative benefit of explanations. And we weren't doing explanations as words; we were doing them as these chart and graph features. But we wanted to see what's really going to happen. And what we found really happened was a little surprising. That AI recommendation only, we actually found that framing effect pretty strong. So this is just the representation, no AI at all as our baseline. And when AI algorithm performance was poor, it it greatly dragged down both for urgent patients or emergency patients at the top and for non-urgent patients. It dragged down the quality of decision making from the nurses. This is nurses and nursing students. We found almost identical, when I added explanations. And again, the thought of, oh, if AI is imperfect, we'll add explanations and then we're going to get this complementary. We're going to get that green line that I showed you at the beginning. And really, not so fast. So we added these explanations, and these curves are almost identical when the red bar is still present. When the red bar is not present and we only have those annotations, those explanations, we get much more attenuated effects of the AI and its performance. But you'll see we don't get better performance, not all the way across the range. We do get more modest gains when the AI is not doing as poorly. We get modest degradation over here. And again, this one actually underperformed across the whole set. So the architecture itself is a problem. That idea of machines giving its inference first, and then the person trying to deal with that's problematic. So again, we wouldn't have known this if we wouldn't have tested. So with this, what we're thinking about is just changing everyone's stances. And in my best Gary Oldman, you'll ask me, what do you mean? What do you mean everybody? And I mean, wait, I mean everyone. We need to be thinking about joint activity here. And when we think about joint activity, this is going to change our stance. This is going to change our governing and regulatory bodies. This is going to change our vendors and manufacturers. This is going to change our healthcare organizations. This is going to change our frontline clinicians. And again, substitute operators there. We need to know things like, and again, I'm going to look at AI and alarms simultaneously here. It's clear that our alarm standards aren't good enough. It's clear that traditional AI, that's verification and validation, it's not unnecessary. It's not sufficient. We have to have evidence of clinician and AI performance together. We and you all can read. We're right there, and I'd rather have time to get to your questions, and maybe we can leave this slide up if people want to comment on this. Actually, yeah. So, or we can come back to it. So we're not going to do the exercise. We're going to get right into conversation and discussion with y'all. So I'd love to turn it over there to discussion. And I cannot believe I made it all the way through that.
Okay, thank you very much, Mike, for this great presentation. Despite those technical issues, we are still on time, and so there are opportunities to some questions and answers. Can you see the chat, Mike?
I
We have
can.
already,
I
yeah, we
can.
have already two questions here. Can you see the one for Ben Williams? I think it's the first one.
Yes.
Okay. Read the question aloud to everyone. How will things change if you are able to place AI outside of the system that the operators use? Wouldn't you expect that embedded AI will suffer from challenges with introspection just as we do? I'm not sure if I got the question.
I'm
Uh,
not sure if I understand the question either. Ben, would you mind unmuting? And can we unmute Ben so we can get that question again?
I'm not sure if Ben is still here. Uh,
Um,
okay.
so
Then
so I'll answer a slightly different question. Um, when we're doing some work with FAA right now about the potential decreased risks if I'm not putting AI in the operational system itself, I'm putting it somewhat off to the side. In aviation, maybe that's the electronic flight bag, which is the iPad that they bring onto the flight. Maybe it's just some analytic tool that they don't really look at before they get onto the flight. And what I would say is that AI right now is blurring all kinds of boundaries that we used to think were very strict and bright line. And the effects, and by the way, when we think about priming and we think about framing effects, a, a a poor inference at any point, whether that's part of the technology I'm using to actually do the work I'm doing or right off to the side, it's still part of the joint cognitive system. So there are still risks there. Possibly they're lower impact risk, but there's still risks there. So I don't know if I answered that question, but maybe I answered a question that somebody else had.
okay.
Um,
I think we can move on to the next question from Garrick.
yes.
Could you comment on how traditional cognitive systems engineering methods, for example, cognitive work analysis, knowledge elicitation, are integrated into GI life cycle, particularly during the design, development, and evaluation phases? A methodological question.
So I skipped that part, and I now know that I shouldn't have. So those are critically important. So understanding that work, those activities, and I think that's really the sweet spot for cognitive task analysis, cognitive work analysis. That is, a cornerstone of ecological interface design as a process. We have a tool. There are a number of folks that have tools that I think do a really good job. I think that the ability of the functional abstraction network from Resilient Cognitive Solutions is a good one to get us focused functionally to get into those activities. The abstraction hierarchy that comes out of the Vicente tradition and cognitive work analysis. We've done some work to make that a little bit more streamlined and work more directly and have more one-to-one correspondence with design. So it's a little bit easier to approach from a designer standpoint. We call them abstraction networks. We've published just a little bit on that as well. Those things are critical. And the other thing that I didn't mention, I think this is, I can answer a question a little bit later. I think it comes from Roland. How did you include experiential knowledge of nurses in your research and the development of the AI? We did exactly that, and we've published. We actually published a paper on the analysis activities, the field work activities on how we set up the AI, what features we used, what's important in nurse decompensation. I'm sorry, in patient decompensation from a nursing standpoint. All of that influenced how the model was designed. So that wasn't LLM based at all. That was old school machine learning. And and so we used that knowledge to say, okay, what should the features be? And then we did a little bit of feature tuning, and then we used the ML process to tune the weightings. So it's absolutely so that was the best possible algorithm we thought we could do using the best possible process we thought we could use. And still, with that architecture, it has serious repercussions for a given patient when that algorithm is performing poorly. So we were trying to have a fair fight there with everybody, or a fair evaluation, and we were very surprised. We thought that the putting that explanation in there would really change the thinking of the nurse and change their behaviors, and it really didn't. Not when that now. Some have looked at this study and said, "Wow, that big red bar is awfully big. Maybe if you had a smaller big red bar, you have less of an effect." My my instinct, my intuition is that's not going to change it, how big the red bar is, but it might. We did make it awfully salient, very salient. So that could be happening, but again, what the model, what data was available to the model and what the model focused on was all the result of those very cognitive systems engineering, human factors analysis techniques, data collection and analysis techniques.
Okay, that's great. Thanks. We have now a question from my colleague, Flavio. Flavio, how do you handle repeatability issues when using large language models in your experiments?
That is the million zillion kabillion dollar question. Um, So the experimentalist in me says, you're probably going to have to control something. And what we've done when we felt we really needed that control was to take real prompts and then get real results and see how different people reacted to those real results. Now, any of you who've used an LLM know that and that's just the way we do it. We don't love it. We don't do it very often. And that's not face valid, right? The ecological validity of doing it that way is terrible, because that's not how people do it. And the everybody who uses LLMs agree that it is well, we would love for it to be repeatable. There are a number of cognitive scientists that say that the lack of repeatability, that's a feature, not a bug. They also say that hallucinations are a feature, not a bug. I am not in that camp. Uh, so what we do is we just lean in, we embrace it. We know that we assume that there's going to be some degree of reproducibility, that they're that, but we trust, but we verify. And and so we look at as we go through the studies, we look at because it's not just repeatability issues because the LLM is not going to repeat. It's repeatability issues because each person is going to prompt a little bit differently. And the LLMs are by design very sensitive to that. So we when, the latest thing we've been doing, and we're just starting to really just cutting our teeth on it ourselves, is we set up a situation where we think we'll get certain levels of performance. We set up situations where we think the LLM is going to do more poorly. We think the LLM is going to do better, and then we just record everything that happens, and we try to understand not only well, first we record how it actually performed when prompted, and we start to use a combination of quantitative and qualitative techniques to describe what really happened. So in a sense, well, this is the beautiful part about LLMs. It's a field study. Even if it's happening in your laboratory, even if you think you have control, it's a field study, because that LLM is not tameable. So we've hit it both of those different ways.
Okay, that's really challenging. Thank you for your clarification. We have a raised hand from, who is raising hand here? He Jiang Ten, can you type your question? He, maybe it was a mistake. Um, sorry, accidental. Okay. I think we skipped the second part of Garrick's question, Mike. I'm not sure
Oh, yes.
if we addressed that part. What methodological adaptations are required to capture, decompose, and reassemble both human and machine role capabilities within envisioned work situations? It's still about methods, but more about adaptations of methods.
What methodological?
Yeah, methodological adaptations are required to capture, decompose, and reassemble. Uh,
Human and machine
uh,
roles.
Perhaps Gary can clarify his question, elaborate a bit more. You can open the mic if this helps, if you are still here.
So Ben had noted that he was having a problem getting his mic unmuted. I'm finding that I can't get them unmuted either. Um, so to Ben and to Garrick, if you could just, if I'd be happy. I'm interested in both of your questions. I just don't understand where you're going. So if you would be willing to restate those parts of the questions, happy to answer them.
And if you are still here, you are free to open the mic. Yeah, but apparently they are not. Well, maybe a final question, Mike. What would be, let's say, key research topics in this field? There are lots of researchers here, lots of practitioners, pressing research needs, or maybe interesting research needs.
So where I think we need to go, and let me sidestep real quick. I know I don't have a lot of time. We've been parts of our community have been talking a lot about AI as a tool, AI as a teammate, um, and then we've been talking about joint human AI systems. And AI as a tool tends to think of research questions like, how do I make it more usable? AI as a teammate. Now I bring in the research of a lot of like IO psychology, the team collaboration research. I think that's really, really very beneficial. The joint work has us start thinking about the functions. And I think where I would encourage our community to think more is how do things like um, how often the person what are the signals for a supervising person when to monitor more closely or when to intervene, or how does the difference between an AI agent leading a certain activity versus an AI agent following, there are a couple different architectures there. How do we best deal with what are diversities of knowledge and processing that turn out to be beneficial? What are diversities in knowledge and expertise? And I won't use expertise, knowledge and processing that turn out to get us working at cross purposes. Like, what are these patterns at a general level that we can start really getting designs on? And all of that starts with a deeper understanding of macrocognitive functions and really honing in on that functional aspect of the work we were doing. So that's what I would advocate that we spend our time.
Okay. There were some two late questions here. Perhaps we have time for just a final one. What about? Do you take it? A final one, maybe?
Sure.
From, let's see here, from Bill Caliardos. Thank you, Mike. Since you are Ohio State, FAA recently funded an Ohio State study by Phil Smith to understand what new recommendations or requirements are needed when air traffic automated system is enabled with AI. I wondered if you all are converging towards similar recommendations.
The short answer is yes. Um, and Phil's right down the hall. Dave Woods is right down the hall. So, I'm leading the FAA project on flight deck. Phil's leading the project on air traffic control. Phil had a different mandate because air traffic control, that part of FAA, they're doing design as well as evaluation. On the flight deck, the FAA is really thinking about certification and evaluation. So our mandate's a little bit different. But we were the first ones to read that report before it went out to make sure that we were in lockstep. And there's nothing. There's nothing contradictory in those two reports, although the focus of ours is a little bit different. And we're about 18 months behind that team. And in 18 months, AI changed a whole lot. So we're that focus you can see when our reports come out, you can see that change in focus, but not a change in message.
Okay, great. Thanks for your patience to address so many questions. Very demanding questions that demand lots of reflection, dense questions. There is a question here regarding recording. Yes, this has been recorded, and this will be available. I think it will be available on the IEA website, and maybe on the Resilience Engineering Association website. Perhaps someone can confirm this for me. Yes? Yeah.
Also in the YouTube channel from the EAI.
So also in the IEA's YouTube
Yeah.
channel.
Yeah.
Oh, okay. Okay.
And
Great.
Tarcisio, we'll upload it to the REA LinkedIn site as well as the REA website.
Okay. That's great.
And then we'll fight. We'll see who goes to which one more to see who wins. So go to your favorite one and we'll know.
We can also put it on the Resilient Healthcare Society's web.
Yes, we have
Please,
another
let's look at it.
another candidate.
Yeah.
That's lovely.
I think Mike put his contact on the slides, his email, so everybody can contact him for follow-up discussions if necessary. And we had here, I think it was a record-breaking audience for the Resilience Engineering series. More than 100 people. I counted 115. So that's great. This
Yeah.
Excellent. Yes, thank you for doing your part, everybody, to support a more resilient world. We appreciate it.
Okay, so thanks again, Mike. Thanks again, the team, for the assistance. So let's move on to the continuation of this collaboration.
Excellent. Thanks so much, everybody.
Bye-bye.
Hey guys, thank you.
Right, thank you.